And I think before start of the lecture, I should take the attendance also. इसकी attendance जो है download attendance list. I should put it downloads this section. Waiting attendance. I should request here, please, section, irrigation, copy. Today's A and D section. Okay, hopefully you are seeing my slides. I have shared the screen, and hopefully you are listening to me also. Attendance have been taken. Most of the time we will be spending in this class, we will be talking about water quantity. So this much water is required by wheat, this much water is required by rice, so much water will be conveyed to the main canal, so much water will be taken to branch. So quantity matters will be discussed most of the time. But you being irrigation engineer, you should also be cautious, you should also be concerned about the quality of the water which is available, or the quality of the water which you people are supplying for agriculture purpose, because not all kind of water is fit for agriculture. So there are certain hazardous chemicals which are dissolved inside the water, which if they are beyond a certain limit, they damage the crops, they damage the soil, they damage the soil permeability, which affect the crop capacity to take water out of the soil. So crop is not only taking water out of the soil, it is this irrigation water is not only providing water, it is also providing important nutrients which are required by crop to grow from the soil, from the dissolved salts in the water. So these good quality nutrients and the bad quality pollutants, both you should be familiar with. So that's why these few slides and we have been put over here. Before telling you the requirements for good quality agriculture water, which we call as a fresh water in rivers or in groundwater, we should be telling you the units which you will be encountered with for measurement of the salts inside the water. Sometimes you see very clear water, but it still contains salts which are dissolved inside it and you cannot see it. Usually this muddy water is because of the suspended particles, not because of the dissolved particles. These these are the suspended particles which are causing the muddiness, or which are causing the uh, color variation. So शहजादे जिसने माइक ऑन किया है या गलती से किया है वो बंद कर दो, और उसने कर दिया, नहीं किया अभी तक। बिलाल, उनका नाम था शेख हसन साहब, बिलाल। तो वो मुझे वहां लेके 3-4 लड़कों को उन्होंने कहा कि भाई मुझे कोई इसको मैसेज करे, भाई मैं तो टाइम नहीं जाया कर रहा, मैं म्यूट कर रहा हूँ। ओके, इसको कहो मुझे मिले फिर बाद में या मुझसे बात करे, ये कम से कम लेक्चर तो नहीं पढ़ रहे, इसको निकाल ही क्यों ना लें, रिमूव फ्रॉम मीटिंग, अटेंडेंस लगवा के भाग गया और क्या। ओके, कहाँ था मैं? So dissolved salts, maybe it is not visible to your eyes, but we can measure their quantity with the help of method we call it evaporation. We take a small sample of the water, we put it in some evaporating pan, put it in the oven, and the water is escaped away through evaporation. The leftover part is the solutes which were dissolved inside that thing, inside that water, and we can measure their mass or grams or weight, and we can see if so much was the quantity, so much grams are there, how much quantity is there in a liter of water. So that is how we measure the quantity of the dissolved salts. If it is something suspended, so that change its color also, and we see muddy water if suspended solids are more. Suspended solids measurement can be done in another way, by what we call it, how much suspended particle have been settled down over there. Those are the large particles. Then we sometimes carry out filtration also. How much particles remain on the filter, that we can measure. And the least, those particles which cannot be retained on filter also, that we measure with the help of the evaporation also. So in this way we measure quantity, and actually we are measuring the mass of those solutes or suspended particles per unit quantity, per unit volume of the water. So an alternate way for measuring the dissolved salts, which changes the conductivity of water. If there is a pure water, it is considered as a non-conductive material. When salts are there, then water gets some conductance. So if we simply measure with the help of some electronic instrument the conductivity of water between between 2 points, that conductivity is an alternate way to measure the dissolved salts in that water. So conductivity measurement के लिए हम ये probe use करते हैं conductivity का, and that is units are इनवर्स ऑफ ओहम. रेजिस्टिविटी का जो यूनिट है, रेजिस्टेंस के जो यूनिट है, दैट इज ओहम. सो इनवर्स ऑफ दैट मोव्स आर द यूनिट्स ऑफ कंडक्टिविटी. So how much mole per centimeter distance is there, that is a measure of the conductivity. And alternate name for mole is Siemens. So Siemens per centimeter or mole centimeter will be the units you will be seeing for conductivity, and this conductivity is related to mass per liter or mass per grams or mass per kg of the liquid, with the help of some graphs like this. On the x-axis of this graph you see is the micromoles per centimeter. ये क्यों नहीं हाइड हो रहा? Okay. On the micromoles per centimeter electric conductivity into 10 to the power 6. So that is related to the other units of dissolved salts. Another unit is called as parts per million. So they can be related with each other with the help of some graph like that. When it is higher value 5000 ppm, then something 4000 ppm is related with about 6 micromoles per centimeter. 6 micromoles per centimeters, and so not equal, but we can relate them with each other with the help of this graph. So other units for measurement of quantity of the solute inside the solvent, inside the water, one is electric conductivity, other units are parts per million, and we can see that parts per million are related with the electric conductivity with the help of that graph. Another unit is called as milli-equivalent per liter. Another units of salts measurement is milli-equivalent per liter. So how that is related with the parts per million or electric conductivity, that will be informed to you. but the basic unit for measurement of the quantity of the salts is concentration of the salt or ions in weight or mass can be expressed in mass unit or weight unit per liter of the water. So concentration of the ions in the water can be expressed in mass per liter of the water. तो इसके units क्या बन जाएंगे? Grams per liter, milligrams per liter, nanograms per liter. So that will be the units of quantity of the salts in water. These ions are expressed in terms of their equivalent weight. Ions are expressed sometimes, instead of simply expressing them as a grams per liter, we express them in in terms of their equivalent weight. And because their quantity is small, so we express them in milli equivalent per liter. So you will be seeing these units as a quantity of the salts inside water, milli equivalent per liter. How to convert that into milligrams per liter or grams per liter? Through an example, we can see that if somebody say that the sodium ion in water is 10 milliequivalent per liter, if somebody tell you the quantity of sodium ion as 10 milliequivalent per liter, so that is actually 10 milliequivalent per 1000 milliliter of water, because 1 liter of the water is 1000 milliliter of water. So we know this already. 1000 milliliter will make 1 liter. So we are converting them into similar unit. This is in milli, so we are converting that also into milli. So it is 10 milliequivalent per 1000 milliliter of water. So now this 10 milliequivalent can be converted into the grams by multiplying this 10 with the equivalent weight of that ion. Equivalent weight of that ion can be found from the book of chemistry. It is that much weight which replaces, I think, a hydrogen molecule or oxygen molecule or carbon molecule in a compound. So you can see its definition, equivalent weight ki definition from the chemistry. We can see table like this which specify the equivalent weight of different kind of ions, whether anions or cations. So equivalent weight is known for all kind of ions. For example, for sodium, the equivalent weight is 23 grams of the sodium is considered as equivalent weight. So 23 grams is considered as equivalent weight. So to convert this 10 milliequivalent into grams, we should multiply this 10 with 23, divide it with the 1000 so that it should be milli on the both side, numerator and the denominator. So we will be getting 10 divided by 1000 into 23 grams per liter of the water. And that we can convert into multiplying with 1000, we can get 230 milligrams of sodium is there in 1 liter of water. If somebody say there are 10 milliequivalent of sodium is there. So 10 milliequivalent per liter of the sodium is actually 230 milligrams of the sodium in a liter of water. So we can convert this simple unit of milligrams or grams per liter into milliequivalent by dividing with the equivalent weight, or we can convert this milliequivalent way of expressing the water quality into grams by multiplying with the equivalent weight and converting it to the whatever units we want to say. So message from here is either water quality or the water quantity of the dissolved salts will be expressed in simple units of mass per liter, that will be milligrams per liter, grams per liter, or it will be expressed in terms of electric conductivity, micromoles per centimeters or Siemens per centimeter, or it will be expressed in terms of equivalent weight of that ion, milliequivalent weight of that ion. So either of these units can be used in different literature. Another way of expressing the salt is how many parts of that salts are there in a million parts of solvent, in a million parts of that solution. If we express the how many quantity or parts of a certain salt is there or certain constituent is there in a million parts of that solution, so that we say as parts per million. Concentration of salts by weight expressed in mass unit mg in a certain weight of the solution, and usually that weight is million times that of the solute weights. So milligrams or kg is related with the million ratio. There are 1,000 grams in a kg, you know it. There are 1,000 grams in a kg. In each gram there is 1,000 milligrams. So the milligrams to kg ratio is million, 10 raised power 6 million. Hopefully everybody know it is 10 raised power 6. Uh, या 10 लाख के जो होता है. So if we express the quantity in a million parts of the solution, so then that unit is called as simply ppm, parts per million. Sometimes we use another units, billion parts, parts per billion, ppb sometimes you see, but not very common. So that will be expressing the quantity of the solute in billion parts. So that unit we use when solute is very small, usually in chemical analysis of our blood or our chemical analysis carried out by the medical personnel. Their quantities are very small, so they sometimes express this unit, parts per billion. Are these heavy metals present in our water system? So those are usually very small, very micronutrients are there. So they might be expressed in ppm or ppb, parts per billion. So we should be knowing what does we mean by parts per million. So if something is expressed in this way for solution having specific gravity equal to 1, hopefully everybody knows what is specific gravity. Specific gravity tells us how much some matter is heavier or lighter than water. So it actually, specific gravity is ratio of the density of a substance to the density of water. So if a specific gravity of something is 1, it means it has a density or unit weight similar to water. So if something has specific gravity of 1, so it has the density of water. So it means it will be having, water has a density of how much? Anybody remember? Density पानी की क्या होती है? Anybody remember?
per meter cube.
जोर से बोलो.
So 1000 kg per meter cube.
1,000 kg per cubic meter. That's true. So another way of expressing it is opposite of that. If I take a liter of water, so then its mass is simply 1 gram. Mass is 1 kg, 1,000 gram. So that becomes 1,000 kg per cubic meter of water, because there are 1,000 liters in a cubic meter, and there will be thousand grams of its mass. So thousand grams is actually 1,000 kg. So 1,000 kg per cubic meter or 1,000 grams for a liter of water. So in case of the solution mix made of water, so if we are talking about salts in water, milli equivalent per liter can be expressed as milli equivalent per kg of water, because a liter of water has a mass of 1 kg, or 1 kg can be expressed as 1,000 grams of water. So that hopefully you understand that milli equivalent per liter can be expressed as milli equivalent per 1,000 grams of water. So that we can say that milli equivalent per kg of water. And we know that the milli and the kg has a ratio of million. So if some salt is expressed as so many milli equivalent per kg, that will be nearly equivalent to parts per million of that constituents. So if somebody say 10 milli equivalent of sodium is there, we can say that 10 parts per million of the sodium are there. So in this way we can express ppm with the milli equivalent, or milli equivalent with the milligrams per kg per liter of water, or conductivity with the parts per million. So these units you will be seeing in the literature, so we should not be afraid of them, we should be familiar with them. Now considering the constituents, depending upon their quantity available in the water, they are divided into primary and the micronutrients, major and the micronutrients. Within the major nutrients for agriculture, these are the primary nutrients which we have to take into account. Nitrogen, phosphorus, and potassium. These are the major nutrients required by the crops. Without nitrogen, they cannot grow. Phosphorus and this potassium are required in a certain suitable quantity. There are some hazardous material also which we should also be knowing that their quantity should not be more than a certain value. Nitrates, which is a substance of nitrogen, and bicarbonates of calcium and magnesium. So magnesium bicarbonate, calcium bicarbonate, and nitrates. These are considered good nutrients for crops. So these should be present over there. If it is not present in sufficient quantity, we apply fertilizer along with the water so that their shortage can be fulfilled. The salts of chlorides and sulfates are considered bad. Salts of chloride, like simple salt, sodium chloride, and sodium sulfate, these are considered bad, injurious. They should not be more than a certain limit, as mentioned over here, that the sodium should not be more than this, chloride should not be more than this, and other sodium bicarbonate should not be more than this. So their limits have been specified. But if nitrogen is more, so that is considered as good. It can increase the fruit size. Excess of calcium and magnesium is not hazardous, so that is not a big problem. Sodium and potassium are injurious, so their limits should be taken care of. So in the book of Iqbal Ali, in addition to these major nutrients, there are small nutrients also, which usually we don't measure with respect to agriculture. We measure them with respect to our drinking water quality purpose. Iqbal Ali table 2.5 and 6 mention the quality of the water as specified by different researchers. For example, Schofield have divided water into these five categories, from excellent quality for agriculture to unacceptable or unsuitable quality for agriculture. And here mentioned the SARS quantity, dissolved SARS quantity in ppm and in electric conductivity units. Permissible water, as per Schofield, is having the dissolved salts up to 1400, 525 to 1400. So average value comes out to be 1000, somewhere close to 1000. So in line with this, WAPDA in Pakistan usually utilize these cutoff values to decide whether the quality of water is good or bad. They have divided water into three categories. WAPDA have divided, and also USGS also uses. USGS is United States Geological Services Group. So they are using these three categories. They call the water will be called fresh water for agriculture or crops if dissolved salts are up to 1000 parts per million. Water will be considered fit for agriculture if dissolved salts are less than 1000 parts per million. Most of our rivers have dissolved salts in this acceptable quantity, 400, 500, sometimes 100 ppm is there in our rivers, in our river system. Groundwater at some place have fresh water quality, and groundwater at some places have saline water quality. It depends upon location to location. Sea water, ocean water have dissolved salts much higher than the hazardous level. Hazardous level is defined as that water which have the dissolved salts more than 3000 ppm. So that water is considered not good for agriculture. It should not be used in that area. Salinity will be the result, crop reduction will be the result, and that should be avoided as far as possible. WAPDA and agriculture allows use of water which has range from 1000 to 3000 ppm after mixing with the fresh water. So that is the cutoff values which we should remember in case of the agriculture water. If somebody say we should apply fresh water, so you should measure it total dissolved salts. Total dissolved salts should not be more than 1000 ppm. Then it will be considered as fresh. Further, if you want to analyze further, Within that permissible value of 1000 ppm, sodium should not be more than 50%. uh, and chloride should not be more than up to 12 hours up to from 10 milliequivalent से ज़्यादा नहीं होने चाहिए. Sulfate should not be more than 10 milliequivalent. So in this way we can further categorize them, but the main category is the total dissolved salt should not be. Similarly, other researchers other than the Schofield have also worked on the water quality. Christiansen, he has divided water into the 6 categories. I think the middle one corresponds to category 2. Where is the parts per million? Category 3 corresponds to something close to our permissible water quality. So 4, 5, 6 are going into the marginal water and the hazardous water categories. So that is how we want to introduce you with the water quality requirements in agriculture. People have carried out surveys of the groundwater quality, and it has been found that out of the total irrigated area, half is underlain with the fresh groundwater. Total, if we take it, it is about 30 million acres. Nowadays, we have 36 million acre of irrigated land in Pakistan. So this is a relatively old table. So out of that, 50% is underlain with the fresh groundwater, and 50% have either marginally fresh or saline groundwater. Most of the area close to the Sindh, close to the ocean, so that is underlain with the hazardous quality of the groundwater. So over there, groundwater is not suitable for agriculture. They are fully or heavily relying on the fresh water being supplied from the river system. In Punjab, we have a lot of area, huge area, which is in which the groundwater is fresh groundwater. In KPK, we have huge area which is having the fresh groundwater, but Sindh has a problem because proximity with the ocean, their groundwater is having high salinity over there. Ocean water usually have salinity as high as 30,000 ppm. The cutoff for saline water is 3000 ppm. Ocean water has so much salts that its salinity is around 30,000 ppm. So I stop it over here. Water resources of Pakistan will be started next time. Some part of this you might have studied in lab also. So if you have any questions, you are welcome. So hopefully this has introduced you with the components of irrigation system and the water quality aspect of the irrigation water. So if no question, I leave it now, stop recording. Thank you very much.